Additive manufacturing is a powerful technology that has made a profound impact in many industries, including aerospace, defense, and healthcare, because of its ability to generate complex parts layer by layer while reducing material waste and shortening lead times for production. Due to high initial costs and serious safety concerns which limit students' access to machines, current education in additive manufacturing is lacking. Thus, the AMVR project was born. To increase student access to critical experience with powder bed fusion machines, we have developed a virtual reality training environment, which allows users to learn the critical skills and fundamental understanding that will help them in their additive manufacturing journey. Through interviews with educators and experts, we were able to define the key requirements for education in powder bed fusion systems, as well as the safety requirements for interacting with these machines.
Let's just say they have too much powder deposited on the build plate. Then, that print doesn't fuse properly to the build plate on the first layer, and then it causes a failure later on.
The powder that we work with is considered a hazardous material. Even if the material itself is not inherently toxic, it's considered a hazard just because of the small particle size. If you're working with reactive materials like titanium and aluminum, then there's an additional hazard, which is a combustion hazard.
Information like this proved a crucial asset to the AMVR design. An in-depth content analysis revealed the areas that were most important to focus on, and thus drove the final decisions for this design. Many tools were used in the generation of ideas and prototypes for the AMVR system. From Mural, a collaborative online brainstorming platform, to Adobe XD, a prototyping application, to Unity 3D, a full-blown game development engine with VR capabilities. 2 main prototypes were developed and user-tested to compare how well the system improves confidence amongst students and to compare the effects of environment realism, known as fidelity, on training. This low-fidelity prototype allows users to look around a room and select personal protective equipment, which appears on their avatar in the mirror in real time. They are then able to move to another room with the powder bed fusion machine and are tasked with placing powder into the machine. This medium fidelity prototype presents a similar environment to the user, but allows the user to move around freely in the environment by walking, crouching, picking up and rotating objects, and interacting with the environment in other ways. Both prototypes have secondary checks designed into the system to prevent the user from accidentally performing an unwanted task. The system also tells the user if they make a critical mistake while performing the task. A final high-fidelity prototype was developed, which allows the user to be fully immersed in the environment using a VR headset. Based on user feedback, it is recommended that the system be developed to have both training and testing modes. All in all, the AMVR project is set up to positively impact learning and training for powder bed fusion technology in additive manufacturing education.